Okay, so I'll just give you some quick facts about who we are, what we do, and what we're especially good at, as you will see. So just a few facts about our team. We are currently about 80 plus people at Ackee. We are still growing constantly, so that's, we've been on the market for around 2 years. So Ackee was founded back in 2012 by, we actually have two of our co-founders here. One of them is Josef in the back, who will be also speaking a little bit more about Ackee blockchain and so on. And Dominic, who was upstairs, you maybe saw him as well already. And Martin, who is not here today, unfortunately. And so what do we actually do? We develop mobile and web apps. What's especially interesting about it is that we actually cover the whole process. So we start with the UX, UI design over the mobile app development front end and back end. So we really cover the whole process of app development in-house, and we don't outsource anything. So that's basically to sum up what I just said a little bit more in depth. So as you can see, we prefer to develop mobile apps natively. In some cases, always depends on the use case, of course, but in some cases we also do it in a hybrid way with, for example, Flutter. And for the references, I won't tell you too much about that. They will be also running on the screen that you see actually back there. So if you see any of the references, I guess you maybe already used some of the apps. For example, the Volkswagen Vischer app, which will be shown also on a later slide, which this one. So if you have any questions actually about the apps that we developed, and if you would like to hear more, just ask me and I'll be happy to tell you a little bit more in detail about all our references. And that's basically it. So thank you very much for your time, and I think Josef will be the next one to tell you a little bit more.
Thank you. So welcome everyone. I'll speak English. Who of you knows what is the web3? Raise your hand. Okay. I have some idea, but like no one knows, Web3 is how we make it, but I will try to explain at least our view on Web3. To begin, I'm Josef, nice to meet you. I'm co-founder of Ackee and Ackee Blockchain. I'm also assistant professor at the University in Prague. And so what is Ackee Blockchain? Ackee Blockchain is a company like within the Ackee family, and we are focused on blockchain auditing. I'll get to the topic a little bit later, but basically, if you develop an app on blockchain, there's a high probability that you will get hacked, and we are trying to protect this. So basically, like, we work for projects to care about their security. And we have teams for Ethereum, team for Solana, so we are able to audit 2 chains. And besides auditing, we are doing a lot of things to move blockchain forward, as we are committed basically like to have some impact in the community. So we are writing a lot of open source software, and we are also running our education courses. One of them is at my home university, and 2 of them are purely online, so everyone can apply. It's free, so maybe you as well, if you'll be interested. These are our tech courses. The second of them is called Summer School of Solana, just finished yesterday, and it was quite high profile because Solana did retweet our announcement about this course. So it was our tweet was in front of 1.7 million followers of Solana. So we get instantly like 700 applicants for this summer school. And you see here, I was trying to capture 666 likes, but then some guy came and destroyed my work, so it's 667, but 182 retweets, we were like everywhere, and for 1 week my phone was unusable because my Twitter was spammed with messages, Discord as well, email as well, so it was quite a high profile event we've created. And as being said, it ended yesterday. Just some interesting numbers. We had 700 applicants. We accepted only 300. We gave them the test, because it was like school for developers. It was not for guys who want to learn how to code. It was for developers who want to learn Solana. And so from these 300 people, only about 14% succeeded in the end. So but still we have like delivered to the Solana ecosystem new 46 developers. So that's our work from recent weeks, and it was quite welcomed in the Solana community. We had a guest speaker, Chase, who is the, let's say, development relationship manager at Solana Foundation. So I'm very glad that we could deliver some high quality and high profile course to actually bring some new people to Solana. So this is just something very up to date. But besides this, what we do for a living is auditing. And as we are like one family with Ackee, we are able to deliver a lot of stuff that no one else can. I think it's like very unique, our setup, because we have a development company, we have an auditing company, and we are able to do some product research, we are able to do UX, UI, we are able to develop front-end, thanks to the front-end team which is here with us. We are able to develop like the Web2 backends, we are able to develop Web3 smart contracts, and then we can audit it after ourselves. So basically like we deliver the whole stack you need if you want to start a new Web3 project. You don't basically need any programmers, we can deliver everything. So this is, let's say, unique about our setup. But enough with the advertising. Last more slide. We have gained kind of good reputation in the community. Reputation is everything in Web3. So we are really happy that we could be working with the high-profile protocols. Basically, like every major protocol that was being launched this year worked with Ackee blockchain. So we audited 1inch, LaterZero, Accelerator, Trader Joe, on the Solana ecosystem, Neon EVM, Debridge. We got grants from Solana Foundation, we got grants from Ethereum Foundation. So this all, I would say, like are the big protocols that were events of 2020. And 2020 year was about bridges. So these are, most of them are bridges. And so, what is the Web3 anyway? Or maybe, who of you knows who is the Web2? Can you raise your hand? Okay, so someone of the guests. So hey, what is the Web2 in your understanding?
Mine?
Yeah.
So I would say like that. I would start with Web1. That like just one part would give you like some content.
Uh-huh.
So Web2, someone would give you the content, but you can also like respond. So it's kind of like interaction.
Yeah, exactly. Good. So you are maybe the first one to answer it correctly, or at least like within some borders. So exactly, like Web 1 was about reading. You know, it was like news servers came to web. You know, so you could read stuff online. That was amazing. You know, Web 2, it was about interaction. So basically, like you could start commenting. You know, you could start creating your own content. So that's like Web 2. And so what is the Web 3? At least in my understanding, is that you are able to read, write, and own. So basically, you are owning some assets that are saved in Web3. You know, so there is no middleman in that, and you are like the owner of the asset, and you can read and you can write. So that's Web3 in a nutshell. If we look at the projects that were launched, so exactly like Web 1 was a lot about infrastructure. So there are browsers, there are the news sites. Web 2 is about social media mainly. So there is like Facebook. There was like the economy that connects people together, you know, Airbnb, Uber, gig economy. And Web3, the first thing that started, of course, is the infrastructure like Ethereum, Bitcoin, and then follow the applications which some kind of use these underlying layer 1 networks. So exactly. But if you look a little bit backwards, so when there's a new technology, you need some basically changes. And what was before Web3 could become, let's say, a little bit the mainstream, was of course there needed to be some Bitcoin. So Bitcoin white paper is dated in 2009. I discovered that in somewhere 2015. So basically I'm quite late comer to Web3 and blockchain. Ethereum was introduced in 2015. So it's like almost 10 years old technology. First MetaMask 2016. So the technology needed to exist. And the second thing to get some revolution is users, and the users must have some kind of reason, you know, to go for the new tech. And the best reason is that the users are pissed, you know. So So as Facebook started, like in the very beginning, it was cool. You know, you could be seeing what your friends are doing. You could be sharing pictures. You know, everyone was there, and it was great. You know, then somewhere around 2014, like our parents started using Facebook. You know, so it little bit was not that cool, but it was a norm. Nowadays, and I would say mainly in Germany, it's evil, you know, because it's using your personal data, and basically Facebook, no one wants to use that, but somehow like people are there, so sometimes you open that, but you are pissed, you don't want to use that, and this makes like the good requirements for the change in the thinking of the people, because like what's wrong with Web 2? You are not paying for anything, you know. Web 2 is free, but nothing is free. So the main problem is in the business model. And the business model is built on data. So basically you provide some of your personal data and you trust the Web2 providers that they give you some service in advance. But of course, like the quote is, when you are not paying for the product, you are the product. You know, Gmail is not a product. You are the product that is providing Gmail with data. And how it became evil is because of the changes in the computing power. All the machine learning algorithms, they are like known since the 60s. The thing that changed is that now you have much more computing power and much more data. And if you combine this together, you are able, as a Facebook, to do really some kind of like evil analytics and predict things and be like in the minds of the users. And this is the place where people don't want to be. So that's the thing that I think are good steps to start a new technology and acceptance of the technology, which is Web3. And Web3 model is driven by something that's called token. And token, you cannot see token, it's a digital asset. And the digital asset is stored on blockchain. So what does it mean? Maybe you have seen a lot of blockchain projects which are like, hey, we will have a token for selling chickens or whatsoever, you know. So usually there is always a token, but the business model is not the token, you know. The token is just a tool for a good use case, so it's not about the token. So what is it about, and how to be able to find out if a project is legit or scam, or at least not a complete scam, you know. So the good things to look at is the token itself. So basically, like, at least the token has to be really stored on a public ledger. There are a lot of private blockchains, for example, like Hyperledger from IBM. You know, a lot of scam projects like use private blockchain solution. You know, that's not blockchain. Of course, the token must be listed on some blockchain, so there's no central authority that can control that. And this is also something that can be a little bit achieved by smart contracts. So if you write your smart contract in a very centralized way, even if you are on a distributed blockchain, it's still not completely distributed and there is still central authority. And then let's say the non-scam project must be controlled by the code, which means like there is no operator of the blockchain project which tells, like, in the bank what's the status on the account. There's in the bank there's some banker who tells your account is this much money. You know, in blockchain there should be no man, you know, who does that. It should be the code who does that. So code is the law. If we look a little bit deeper at the technology of the blockchain ledger, so basically this slide is something that I can talk about like 1 hour at the university lesson. So in a very nutshell, if you're not familiar, how does the still most common, let's say, type of blockchain work? It's a proof of work chain, which is Bitcoin, which is Ethereum nowadays. And it's based on a process that's called mining, which means there are some people who are running nodes, and these nodes are doing something that creates new blocks. And every block contains, to be very simple, a link to a previous block and some data like transactions. So with this principle of linking of the blocks, you are able to always track to the very first block. So you can see that the transactions, the changes of the state of the blockchain happened, when did it happen, and for example, if someone fakes a transaction, or there is some random block which cannot be tracked to the origin block, you know that it's not the blockchain you should trust, because always like the block needs to be tracked to the very first, it's called genesis block. So this is like in a nutshell, the principle of blockchain. How are the blocks created? It's the mining process, or it can be a process, for example, which proof of stakes uses. So there are a lot of principles behind that. I will not go too much deep into it, but still, like, all blockchains are based on blocks and links between these blocks. So what are the changes between Web 2 and Web 3 from the tech perspective? This is like a very simplified scheme of Web 3. So basically, you're a user, you have a browser, in the browser you have a wallet, and there's this thing. In the browser there is running some front-end application. That's still the same code as you write for Web 2. The only difference is that this front-end application is communicating with the wallet, and the front-end is communicating with the blockchain. So basically, this mechanism allows you to have your assets stored here in the wallet and not somewhere here on a server. How does it look like? I guess some of you are familiar. This is a MetaMask wallet, the most common one. So it's for example, Chrome extension. You have here your blockchain accounts. And this is like a more tech picture. So if we compare the Web 2 stack and Web 3 stack, the simplified picture was, let's say, oversimplified, because still in Web 3, you have some parts of the Web 2 projects, which is, there is a front-end application, there is some internet connection, and there is some back-end application. It was like one of the topics somewhere in 2018 that, you know, if you are doing blockchain application, you should skip this part. So of course it's not true, like you cannot have everything on chain, it doesn't work. So even with Web3 apps, you still have like classic stack of application logic running on the servers. There's a database server, but the point is that the assets that need to be trusted are not stored here, but are stored on the blockchain. So yes, there exists some logic, but the tokens are here, not here. And so, like, what's the typical stack? There's like many blockchains, so I will explain the most used one, which is Ethereum. And Ethereum also has a lot of different types. Ethereum basically means Ethereum virtual machine. But there's like mainnet Ethereum, there's a Polygon, there's Avalanche, so there's like a lot of layer 2 solutions, but now we will speak basically about Ethereum as EVM. And this thing can run something that's called smart contracts, which Bitcoin cannot. Bitcoin is just the one asset. But here, actually, you can be running something like small programs on the blockchain. What is it? It's basically an application that's running on the blockchain servers, which means on the nodes of the Ethereum network. And on every node of the Ethereum network, you are running the very same program. So like from the database point of view, you are replicating all the data to all the nodes. And these nodes and these data are changed by a thing that's called transaction. So the transaction has to go from one state to another. And the nice thing about it is that the transaction is visible on the blockchain. So basically, you as a user can see what was changed between one stage and another stage, and the stage is the block. So between block 1 million and 1,000,001, you can really like look with Etherscan whatsoever and see what data changed. So it's like completely transparent. The other thing is that once the transaction is confirmed, you cannot change it. So basically, like if you send somewhere the tokens, it's sent. If you make a mistake, you make a mistake, but you cannot go back in the chain. You know, no one can do it. So this is another feature, let's say, of Ethereum and of blockchain. And the transactions are final, which means also like it happened, which implies the single statement, code is the law. So basically, what is written in the smart contract, that happens, and no one can change it. Unless some exceptions. I'll talk about it later. And how is it done? So basically, like on every node of Ethereum network, there's running this thing which is called Ethereum virtual machine, which is basically like a simulation of a very simple computer. This is how computers used to look like in 60s. And this simulation is running on every node. And for example, if you here increase the program counter, so you increase it by transaction, and this transaction has to happen on all the nodes of the network, which of course maybe you will now think is very slow. And yes, it's very slow. So like this computer is running on every node of the Ethereum network, and if you do a single operation, the operation needs to happen on every node of the network. This is how it's designed, but it's very robust in that case. And how does the code look like? So if you're a developer, maybe you're familiar with JavaScript or C languages. Ethereum is programmed, for example, in Solidity. And Solidity language is like very simple. Even I'm able to read it, which means it's simple. And so basically like everyone can, after some learning, code in Solidity, which is great. However, it's not just about writing in Solidity, because the code is easy to write, but Ethereum as a distributed system is hard to understand. What does it mean? There are some changes from Web 2, and these changes are exactly these points. Code is immutable, which is a new pattern. You know, if you deploy a broken code on a Web 2 project, you redeploy and it's fixed. If you deploy a broken code on a Web 3 project, someone hacks you and you are over. Also, you have to pay for the execution. That's something that's called gas fee. You are probably familiar with that. And the gas fee is used for the miners as their motivation, you know, to change the states and find new blocks. So basically, as the code you program has to execute on every node of the network, you have to pay to these nodes. So it's expensive. So you have to look at the optimization to do as less operations as possible in order to not pay for everything. That's the reason why there is still the Web 2 backend, you know, because the things that doesn't have to be on chain, you offload to the Web 2 backend because you don't have to pay for that. And also, as being said, everyone sees your program and its state. It's something that you don't know from the Web 2 ecosystem as well. You know, if you write a Web 2 backend, so no one can look inside. But here, like everything that happens through the transactions, every user can see that. And all this stuff is running in parallel on many nodes, you know. So it's like a really complicated distributed system, which of course is something that you have to be thinking about. So it's not just about the code; it's about this. It's called Ethereum yellow paper. And when at Ackee blockchain we are onboarding new people, this is something that they always start with. So that's like quite hard mathematics and formally specified EVM. This is Ethereum, because if you ask what is Ethereum, there is no like foundation that is Ethereum. Of course, there is Ethereum foundation, but it's not Ethereum, you know. So it's not Vitalik. It's not some code. Ethereum is this white paper, and the people follow what is written in this white paper, which is called yellow paper, and this specifies the Ethereum language. And this is something that, like, the people who want to be good at Ethereum should start at. And it takes about, I would say, 3 months to fully understand the paper. And also, this paper is still evolving. For example, 2 of my students who were working with some security projects as their master thesis have discovered a mistake in this paper, and they have submitted a pull request, and it was accepted by Ethereum Foundation, so they became one of the contributors to the Ethereum yellow paper, and there is only about 300 people on the world that are contributors here, and now they can be, you know, hanging in the bar and telling, hey, I'm one of the contributors of Ethereum, you know, I basically create Ethereum. Of course, the mistake they've discovered, one of them was a typo, and the second one was some like very stupid mistake in mathematical brackets. So it was like very, let's say, cheap things, but still, they are the contributors, and there's only 300 people in the world that can do this. So if you would like to start with Solidity, start with the yellow paper, and if you are in Czech Republic, you can attend my lesson. Or we have this online summer school, which will probably start this fall, so we can sign up and learn something about Solidity. And so why is not everyone in Web3? Here are some of the common problems. So if you want to adapt new technology, you need people. Clever. One of the problems of Ethereum is that it's very expensive. And it's again like on every node, you have to do every operation, so it's slow, and slow means you have to pay a lot for the miners to do the operations, which means it's expensive. So there's a solution which is called Ethereum 2, and Ethereum 2 was announced like a long time ago, and it's still not on the mainnet. Ethereum 2 will be not proof of work, but proof of stake, so it will have a little bit lower gas fees, but the main problem still remains, which means every operation needs to happen on every node. So that's the reason why there are like many more chains. One of them is, for example, Solana. From the computer science point of view, Solana is really well designed, distributed system. Things are running in parallel, which means like the same operation doesn't have to execute on every node. There could be just some kind of consensus. So it's not just about Ethereum. But Ethereum is still some kind of, let's say, main blockchain which has a smart contract capabilities. But the reason why it's not everyone using Ethereum, if you want to mint an NFT on OpenSea, you pay like $100 or $200 just for minting that, and this is of course like unacceptable, So that's the reason why are there side chains and why, for example, Solana NFTs were skyrocketing because the fees are not that high. Another problem, people write the code. When the code contains bugs, everything is immutable, so if you make a mistake, you will probably get hacked. And speaking about hacks, the first hack that happened on Ethereum was back in 2016. And back in the day, as Ethereum was very new, the people didn't recognize between smart contract on Ethereum and Ethereum, because it was like, okay, there's Ethereum, there's some project, and the project got hacked. The problem with the hack was it was a typical re-entrancy bug, which happened in the smart contract of DAO. So it had nothing to do with Ethereum. The Ethereum was not hacked, but the project on Ethereum was hacked. But this project had a really big impact then, and like most of the Ethereum users have been participating in DAO, which means if DAO would end, probably Ethereum would end. So what did they do is that the community led by Vitalik decided to basically go back into the blockchain, which means basically they just deleted the transaction after the hack. They fixed the code of the DAO smart contract and continued from that point, which of course doesn't mean this. And there was like a big clash about it, if it's correct to do it or not. From the point of view how we understand blockchain, it's completely unacceptable to do this. So there was and in the technological point of view, Ethereum did a hard fork, which means like there was a chain of Ethereum, and then at some stage, people declared, okay, from this block, it was the block before the hack, we change the rules and create a new chain, which we still call Ethereum. And the chain that didn't change, that included the bug, is called Ethereum Classic. So basically, like Ethereum Classic is Ethereum which with the DAO hack inside, and Ethereum itself is basically like fork of Ethereum Classic before the hack happened. So it was the first time and the last time that basically like Ethereum got hard forked. Just for your information, if you write a smart contract and you make there some shitty mistake like Deo team did, Vitalik will not do a hard fork again, you know. So now you have to really look at the mistakes, you know. So this is something basically just to demonstrate that code is the law was broken once, but probably will not be happening again. And so what did happen in this DAO hack? The bug is called reentrancy bug. The sad thing is that it's 2016. Now we are 2022, and we are still, as auditors, having projects where we find reentrancy bugs. The good thing is we are making some decent money on it, you know. And maybe I will just a little bit explain what is going on. I'll try to be like very non-technical. So this is the code of the smart contract. And as you write the code, usually it's executed line by line from this point to this point. This is the behavior everyone is used to, you know, from JavaScript whatsoever. And what is here happening? There's some function, and the function is doing that. It's sending whole balance from one address to other address. It's this line. And if this happens, it updates the balance, which means like I've transferred the resources from one point to another, and now I mark myself as a smart contract that the resources have been transferred. Looks clear, okay? So what's happening? User will call the smart contract, the funds are transferred, and then the balance is updated. So it's okay. But if you read the yellow paper, you will know that you can call a smart contract as a user, or you can call a smart contract as a smart contract. And if you call a smart contract as a smart contract, you can do one thing extra, which is you can implement a special feedback, a special callback from a function, which can do some stuff. So in this case, if the attacker writes a smart contract, he runs the smart contract, and the smart contract calls this function, and here implements a callback. So this line, which updates the balance, is not executed, but first we are going to execute a callback, and the callback calls again this function. So this line again sends you all the balance, and then you're again going to fallback, and this fallback again sends you the whole balance. And with this recursion, basically it's being executed before you drain all the balance from the smart contract, because it gets never updated here. So it's the reentrancy bug. The solution is very simple. Just change the order of these two lines. First, update the balance, then call the withdraw function. So this is like very oversimplified explanation of the reentrancy bug. You can see that it's nothing like rocket science. It's just if you are used to work in some way which goes like from up to down, and you don't know about this special thing that smart contracts can do, and is the callback function, you will probably write it this way. Okay, and so how to eliminate these problems? Of course, you need to write good code, which is easy to tell but hard to make. So for this case, there exist guys who are called auditors. Blockchain auditors, they are not the people who look at your finances. They are people who look at your code. And for example, for you as a user, if, I don't know, you will be putting money to some DeFi protocol, so just please like look if it was audited. That's like the first step. But the audit, it doesn't mean like it's audited, it's safe. You know, there's like a lot of things that can happen and go wrong. So audit is not stamp on security. It just tells that, okay, someone at least did check the code. So how to increase the probability of having your funds safe is that the project should be audited before every release. A lot of the scammy projects are audited once. You know, they launch a protocol, they put the audit on their website, it's safe, it's audited, but then they do changes to the code, and these changes are not audited anymore. You know, so that's you have to check if the audits are still like catching up with the code base. And of course, like none of the auditing companies can tell our audit is 100% safe. So the best protocols, like for example 1inch, they have for every release 2 to 5 audits from 2 to 5 companies. Of course, it still doesn't mean that it's 100% secure, but at least like some number of clever guys did have a look at the code. And of course the problem is that there's like many blockchain projects and just a few auditors, and auditors are a bottleneck of the releases of new features. So we always tell to the projects, book your slots in advance. We have usually quite a long pipeline, and of course it costs some money. Okay, I don't know if you have time. What's our time? Can I speak like 10 minutes more? No. Okay, I'll skip it. For you, okay, I'll just do a very quick. What is it an audit? Okay, so I'm opening one of our audits. Hopefully we can see that. So it's a PDF. I'm always telling like we are selling PDFs. This is audit of Axelar. It's public, so you can definitely check it. It's on their website, you know, and you can see in the repo that they have a audit. And yeah, it's very small, but you can see there's not one, but like many audits. And if you have like 5 minutes, then where to look at the audit is executive summary. I'll just open it here. And just read the executive summary. It's like the very least thing you can do. And basically here we write that Axelar asked us to do security audit. There's the date when it happened. So for example, if you find this audit like in 10 years, that probably it's outdated. Here's written what we have audited. And here are some things that we are focusing. And the important part is here. Code quality is very good. Tests are well written, blah, blah, blah. Yeah. Our review resulted in 9 findings. So we have found 9 things that can be wrong, ranging from informational, which is nothing, to high severity. High severity, it's probably like could be a problem for the protocol. So this audit tells that we have discovered something that could be quite wrong in the protocol, and you have to check for the update. And this update, it tells that findings, apart from fixing high one issue, that's the high severity issue, some of the issues were left, but okay, at least the high one issue, the high severity issue was fixed. So you know that the biggest problem they have discovered, they fixed that. Okay, so I would say fine. For example, if here wouldn't be this appendix, so you will probably know that we have found a problem in the protocol, but they didn't fix it. Here we are sure, okay, they fixed that. And that's all you need to do with the audit. Yes, user. Cool, 5 minutes. And just some few last slides. What I find as good examples of Web3 apps. You have probably heard of NFTs. NFTs are still quite hitting hard. And I think it's going to be a mainstream in marketing of big brands. Because, for example, you can do with quite a low budget, create a website where every user of your campaign can, click something, have some collectible, and it's a very nice use case that the users have something in their wallet, and it's not very expensive to develop such a thing. If anyone would be interested, we can do this. For example, Adidas has launched their campaign with NFTs. Second good example is that a lot of the blockchain projects basically are not a company, they are DAOs. What does it mean? It's a decentralized autonomous organization. So basically, all their management itself is happening on the blockchain. So for example, if they are voting about new feature, voting about salaries, voting about which auditing company should be included, they always have some kind of discussion forum, and they have their shares in that represented by tokens, and they vote about things. So that's like another type of organization. And for example, 1inch, very popular exchange, is completely decentralized. So they are doing all the decisions on chain. They don't have an office, they don't have a company. They are just living somewhere in the blockchain. Okay, so the last slide. Is it the hype? Is it not the hype? We don't know. But what we can know for sure that there's new technology. And for example, as cloud was introduced or big data were introduced, everyone's speaking like, hey, the next thing is big data, next thing is cloud. But then it becomes like part of the ecosystem. And now, for example, when we are processing a bunch of data, we don't call this is a big data application. It's a normal application that's processing a lot of data, you know. So I think the same thing will happen with, let's say, Web3 or blockchain. So you will not have like special Web3 bank. Just your bank will start accepting your MetaMask wallet, and you can have assets like in the bank and in your wallet, and it will some kind of like merge into the mainstream, and we will be speaking about web, not Web3, and everything will go like it happened in the past. So that's like my last word, that buzzwords will go away, but the technology will remain. Okay, thank you. That was my presentation.